Hey everyone, and welcome to today's Explainer. We've got a truly wild story for you today. One where a massive environmental crisis meets some absolutely incredible human ingenuity. You might notice this really cool kind of techno-organic steam aesthetic guiding our journey today. Well, that's intentional. It represents exactly how we're merging the raw, sometimes totally chaotic forces of nature with sharp structural engineering and pure data logic. We are diving into the sargassum seaweed phenomenon and looking at how some brilliant innovators are taking a massive ecological headache and turning it into the literal foundation of communities.
So meet the sargassum monster. Now, for years and years, this free-floating brown algae was just, a normal natural part of the ocean ecosystem. But recently, this natural phenomenon morphed into an absolute coastal nightmare. It has just been walling beaches all across the Caribbean, the Gulf of Mexico, and West Africa. It's incredibly smelly, it's super disruptive, and honestly, it really does feel like an unstoppable, invading force of nature.
Okay, let's dive into this, because that right there is exactly the central question we're tackling today. How in the world do we take a totally uncontrolled environmental hazard, literally an ocean monster, and engineer it into the building blocks of a sustainable, circular economy?
To figure that out, here is our roadmap. 1. The sargassum monster awakens. 2. Environmental and economic toll. 3. Strategic offshore interception. And 4. Building a circular economy.
Okay, Section 1. The sargassum monster awakens. The history of this problem is actually surprisingly long. Christopher Columbus first reported seeing sargassum way back in 1492. And for centuries, it mostly just stayed contained out in this 2 million square mile area called the Sargasso Sea. But then, in 2011, everything changed. We started seeing these massive, completely unprecedented influxes just slamming the Caribbean. So why the sudden shift? Well, scientists point to a perfect storm: rising sea temperatures, shifting ocean currents, and a huge spike in nutrients. Basically, global runoff from agriculture and mining is carrying all these fertilizing nitrates and phosphates down major rivers like the Amazon, the Orinoco, and the Congo, dumping right into the ocean and essentially supercharging the algae's growth.
And so, what's happening now is that those ocean current gyres, the swirling currents that traditionally kept the Sargasso Sea kind of locked in place, aren't containing it anymore. Independent, massive rafts of sargassum are just breaking right off. They're traveling thousands of miles from the Amazon and the Congo deltas, riding those currents and feeding directly into the Caribbean and the Gulf of Mexico.
Which brings us to Section 2, Environmental and Economic Toll.
The reality on the ground, or I guess on the beaches, is incredibly tough. When this sargassum washes up and starts rotting in the sun, it releases hydrogen sulfide, or H2S gas. And guys, this isn't just a bad smell. It actively causes real health problems: respiratory issues, headaches, dizziness. Plus, we absolutely have to talk about the human element here. The shoreline cleanup workers are out there dealing with this daily. Many are using just, basic pitchforks and wheelbarrows to move tons of this stuff, risking exposure to heavy metals like arsenic. And sadly, reports show many of them are operating completely outside of municipal contracts, which means no proper insurance, no physical protection, all for a biweekly salary of maybe around 6,000 Mexican pesos.
And then there is the sheer economic hit: $120 million. That is the estimated annual cleanup cost in the Caribbean alone. Think about that. When your world-famous beaches are suddenly buried in rotting seaweed, the local economy takes a massive nosedive. To put that in perspective, tourism on Mexico's Caribbean coast dropped by an estimated 35% in 2018, strictly because of this sargassum inundation. But hold on to that $120 million disaster in the back of your mind, because I want to contrast it with this. $12. Yep, just $12. That is the cost of a single commercially sold building block made from this exact same nuisance seaweed. It's an incredible turnaround. But to understand how we actually get from $1 million disaster to a $12 brick, we got to look at the logistics.
Section 3. Strategic offshore interception. Because let's be real, you can't catch what you can't track. Today, there's a highly sophisticated array of mechanisms deployed to predict exactly where and when these blooms are going to hit hardest. We're talking about complex NEMO-SARG mathematical distribution models, high-precision satellite imagery, drone mapping, and even cool citizen science programs like SARG-SNAP. There's also predictive software out there, like the CLS SAM tool, that provides near real-time forecasts of the blooms.
And tracking it is the ultimate game changer. Because if specialized teams know exactly where the seaweed is going to pop up, they can act proactively.
Instead of waiting for it to rot on the sand, they can reach out to local governments, request the necessary harvesting permits, which honestly has traditionally been a huge policy hurdle, and even secure service contracts and upfront payments to remove the material for them before it ever becomes a shoreline disaster.
But there's a pretty massive logistics challenge here. Sargassum influxes are highly variable and super seasonal. So buying incredibly expensive, specialized harvesting equipment just to let it sit inactive for half the year? Yeah, that doesn't make financial sense. The solution? Complete adaptability. Companies are renting collection machinery and processing facilities purely on an as-needed basis. And here is a really fascinating parallel. Think about agricultural workers who already migrate regionally, right? They move from place to place as different land-based crops are ready for harvest. Well, because the sargassum harvest peaks during the off-seasons of other industries, it presents a perfect opportunity to hire those temporary, seasonal workers. They can simply follow the algae blooms, much like they already follow traditional plant harvests.
So the real key here is that this flexible workforce and the rented equipment allow for preventative offshore harvesting. Using specialized tools, like these LCM frames that hold massive collection nets open on either side of a boat, vessels can just skim the sargassum right off the ocean surface. Companies like Algae Nova are operating vessels that catch up to 130 tons of sargassum at sea every single day. When a net gets full, they just drop it in the water for a secondary boat to haul away, instantly swap in a fresh modular net, and keep going without missing a beat.
Section 4. Building a circular economy.
Now, while processed seaweed is being used to make things like cardboard, adhesives, and activated carbon, one of the most exciting commercial opportunities is definitely the sarga block. And the manufacturing process, brilliantly simple and efficient. First, you dehydrate and crush the sargassum until it makes up about 40% of your mix. Then, you blend it with limestone and organic pruning waste, feed the whole shebang into a block-making machine that compresses it, and finally, you just let it sun-dry for 6 hours. That's it. It requires very little water and absolutely zero baking.
No, what's really interesting is how we actually classify this material, because a sarga block doesn't really behave like your standard, traditional, load-bearing masonry brick. Since it's combined with stabilizing additives and sometimes even recycled plastics, it actually functions way more like a plastic composite lumber. This means it has fantastic dimensional stability and water resistance, which makes it absolutely perfect for exterior commercial applications. We're talking outdoor decking, facade cladding, fencing, landscape structures. You can literally even cut and drill it using conventional carpentry tools. And the construction benefits are just off the charts. Using these blocks commercially can lead to a 30 to 40% reduction in overall building costs. A huge chunk of that comes from a massive 70% savings in cement and rebar. Plus, the blocks are designed with internal cavities, which makes running plumbing and electrical a total breeze while also adding thermal and acoustic insulation. Oh, and absolutely crucial for the Caribbean region, the National Autonomous University of Mexico actually tested and confirmed that these blocks are highly resistant to earthquakes and hurricane-force winds. And listen, this isn't just some pie-in-the-sky prototype. This is a full-blown commercial reality right now. In 2024 alone, over 2 million sarga blocks were produced. They're out there being used to build schools and community centers. In fact, 13 entire homes have already been built and donated to low-income families in Quintana Roo.
The inventor of the sargassum block, Omar Vasquez Sanchez, sums the whole thing up beautifully. He says, "We help clean up all of the sargassum, which kills fish in the reef, and we create jobs for people in need." It's an amazing story. He grew up working in those same agricultural fields we talked about, and eventually turned his local nursery business into a real, tangible solution for a global ecological disaster.
So let's bring it all together and look at the big picture. By relying on really sharp tracking data, we can enable strategic offshore interception that neutralizes a literal toxic health threat before it ever touches the beach. It then allows governments to redirect their desperate cleanup funds into preventative tech and migratory job creation. And finally, it provides the raw material science needed to create sustainable, totally affordable housing materials that actually help restore local economies.
It's kind of like taking control of chaos, right? Going from this unpredictable natural crisis and harmonizing it into the very foundation of a community.
So I'll leave you with this final thought today. If a toxic $120 million environmental crisis can be systematically tracked, harvested, and compressed into a simple $12 building block, what other global nuisances out there are actually just raw materials, just waiting for the right innovator to come along? Thanks so much for joining me for this explainer, and hey, keep looking for the solutions hidden inside the problems. See you next time.